this is a really good question because it's really just testing, like, do you truly understand what trigonometry is, or you just kind of have like a vague understanding? So what most of us are going to do, and what we should do, is we should write SOHCAHTOA on our page, right? This is, to me, a formula that we just need to memorize for the SAT, because SOHCAHTOA is the way that we remember sine, cosine, and tangent, and where all the pieces go. So the tangent part is what we're going to first care about, because that's what they tell us, right? So tangent of angle B is equal to the opposite over the hypotenuse, so over the adjacent. So 3 over 4 is the opposite over the adjacent. That's what the O and the A stand for. So let's go to B, right? So that's here. And then that would mean, okay, the opposite of B is the 3, so that's here. And then the adjacent side is BD, that's here. And that's because BE is the hypotenuse, right? So, okay, well, that's a little weird. Because if I look at this picture and I look at the other information that I'm given, DA is 4. And BC, this whole thing, is 15. So how is it that DA and BD are both 4, right? I mean, that's kind of strange because BD looks bigger than DA. And there's no note here that says that it's not drawn to scale. So that means that I should assume that this picture is, in fact, drawn to scale. Well, that's because what I wrote down isn't really true exactly, right? DE is not 3. BD is not 4. There's a reason we call these trigonometric ratios. What they tell us is the relationship between the sides of a right triangle. They do not necessarily tell us the actual lengths of those sides. So when they ask me for the value of DE here, I should suspect that something is up. It cannot be 3. There's no way that I should be able to get this answer just using that and not using the 15 and the 4 that they gave us in DA and BC, right? Like, that should be suspicious in and of itself. The SAT does not give us information that we don't use. So if we find ourselves with extra information at the end of a problem, it's not a great sign. It usually means that we've messed up. So somehow I got to incorporate that. And the way to do it is to recognize that B, yes, it's that angle at the top. But tangent to B could also be talking about the big triangle. Right? So the relationship between the opposite and the adjacent also holds for this big triangle. Meaning, in some way, if the opposite of B is 3, then somehow AC is also 3 because that's also opposite. And BA, the adjacent side, is also 4. And that's because that's the fraction. And again, the relationship is 3 to 4, not the actual measurements. So what could happen is that instead of having 3 and 4, we have something like 6 and 8, right? Because what is 6 divided by 8? It's 3 over 4. It's the same fraction, right? It could also be 9 over 12. Basically, a trigonometry statement tells us the relationship, but it does not necessarily tell us the exact values. And we've got to use this DA and BC to kind of figure out what the actual values are. And we can do that because there's another very convenient thing going on here. And it is that we have 3 and 4, and so the other piece of this is 5. So this is what's called a Pythagorean triple. 3, 4, 5. This is a very convenient set of numbers because it produces a situation with a right triangle where Pythagorean theorem works out very, very nicely without us having to deal with decimals. So, right, if we had a right triangle, 3, 4, 5, a squared plus b squared is c squared. So that's 3 squared plus 4 squared is 5 squared. 9 plus 16 is 25, and that's true. So when we see 3s and 4s and 5s on these trigonometry questions in the SAT, we should assume that we're dealing with one of these very special, convenient right triangles. But it's not just that 3, 4, and 5 work because of the ratio. Anything that fits that ratio is also a possible triangle that's really convenient, right? So if we doubled it, we'd get 6, 8, 10. If we tripled it, we'd get 9, 12, 15. And what do you know? That 15 is there. So what we have is a 3, 4, 5 triangle that's not actually a 3, 4, 5 triangle. It's these other versions of that ratio. So if that big side BC is 15, then that means this small side down here, AC, it's not 3. It's in that relationship, but it's actually 9. And this big side up here, well, it's not actually 4, it's actually 12 because it's in that relationship. 9, 12, 15. And so we can now go to the little triangle and see that the 3 and the 4, again, are not the actual measurements. They're just capturing the relationship. So the yellow triangle is this. Let's get another triangle in there. Let's do pink. There we go. The pink triangle is the 6, 8, 10. And how do I know that? Well, right here, if I know that this is 4 and this is 12, then the leftovers have to be 8. And if that piece is 8, then by default, this part has to be 6 to match the relationship. So there's your answer, 6. Whew. To me, this is kind of as tricky as trigonometry gets in the SAT. Maybe there's some other things that are a little bit harder, but this is taking the normal SOHCAHTOA, which we absolutely need to know, and then it's twisting it up by, kind of trying to slip it by us that the relationships, sine, cosine, and tangent, are really just fractions that are completely simplified. And we forget that, and what we need to do is we need to kind of unsimplify those fractions and figure out what's going on with the real triangles that we're given, that have real dimensions, right? So let me just show one last thing, I guess, is if I were to go back to the tangent of B and look at the pink triangle, right? Tangent of B, like I said, is the opposite over the adjacent. The opposite of B is 6, and the adjacent side right here is 8. 6 over 8, which I would never write because that's bad form. I would write it as 3 over 4, which is what they gave it to me as originally. Normally, that's the progression. We start with the big sides, then we end up reducing the fraction. The SAT, of course, likes to take what we normally do and reverse it, and so this time we're being given the reduced fraction, and we got to unreduce it so we can understand the picture. This is a good one. This is a good one. Well-earned points here. If you had trouble with this is fine to skip and try to go on to 37 and 38 and see if you can get those points instead. This definitely requires some memorization and some confidence with trigonometry, and that's an advanced topic.